Hello everyone. In this example, we will understand the concept of maximum power transfer to any load R for a dependent source circuit. Here there is a voltage dependent voltage source. Its value is 2Vx. That Vx depend upon 6 ohm voltage. Now for the calculation of this load resistance R, our maximum power transfer condition is this R must be equals to Thevenin's equivalent resistance. And the maximum power calculated for this load resistance will be Vth square divided by 4 RL. RL is the load resistance, Vth is the Thevenin's equivalent voltage. Here this RL is R, which will be calculated by Thevenin's equivalent resistance. Our maximum power transfer condition is this load resistance R must be equals to Thevenin's equivalent resistance. For a dependent source circuit, this RTH can be calculated by two methods. Our method one is we will replace all the independent sources by their internal resistance and remove the load resistance and connect a source. It may be a voltage source or a current source, and take the response. That response will be the voltage divided by current at this load terminal. That will be calculated as RTH. And our second method is we can calculate our RTH by taking the formula, that is VTH divided by IN, or you can say open circuit voltage divided by short circuit current. Here we use our method 2, which is VTH divided by IN, from which we will calculate our RTH for this particular dependent source circuit, and also calculate our maximum power by this VTH calculation. VTH is Thevenin's equivalent voltage, which is calculated as open circuit voltage of load terminal. So this is our network for the calculation of VTH. Here we remove the load R and calculate this VTH. For the VTH calculation, we have to calculate the currents in this particular circuit. If you analyze this 3 ampere current source that is connected with 6 ohm resistance in parallel, you can think about the source transformation, but in this circuit this is not possible because its value 6 ohm voltage Vx depend upon this dependent source voltage value 2Vx. If we apply source transformation, then this Vx will be changed, the circuit parameters will be changed, so the dependent source value will be changed. So remain the circuits intact, we cannot change this particular 6 ohm resistor. So calculate this particular network in this condition, and for the calculation of current for this network we will apply nodal analysis. For nodal analysis, one node as a reference node and assume other node voltages. Here we assume this is our reference node and this node voltage is equals to Vx because this node is connected to a 6 ohm resistor through a node voltage 0. So this voltage Vx is the node voltage. Now assume the branch currents. Here we assume this 3 ohm branch having current I1, 6 ohm branch current direction according to the polarity, this is I2, and it has 0 current because it has open path. Now apply KCL at node. Our KCL equation is incoming current is equals to outgoing current. Incoming current is I1 and outgoing currents are I2 plus 3. Now see the values of I1 and I2. If you analyze I1, that is initial voltage 0 minus final voltage Vx plus source voltage in current direction, that is 2Vx divided by 3. So this I1 is Vx by 3. Now see the value of I2. This I2 is Vx minus 0 divided by 6. Put all these values. This I1 is Vx by 3 and I2 is Vx by 6, and calculate this Vx. Our calculated Vx is 18 volt. Now analyze the network for VTH. VTH is basically is equals to Vx. If you see that this path consists of this 3 ohm resistor, and see the polarities are same, and this has 0 voltage. So our VTH will be is equals to Vx. Calculated value of VTH is 18 volt. Now calculate Norton's current for the calculation of resistance R. For the calculation of Norton's current, we will short circuit the load terminal, and this current is defined as Norton's current. This Norton's current can be calculated by simple nodal analysis. So apply the nodal analysis in this network. Same concept, assume a reference node and other node voltage. Here this node as a 0 volt, and assume this node as V volt, that is equals to Vx. Assume branch currents, that is I1 dash, I2 dash, and this 3 ohm current will be Norton's current IN, and apply KCL. Put the values of I1 dash, I2 dash, and IN. I1 dash is 0 minus Vx plus 2Vx by 3. I2 dash is Vx minus 0 divided by 6, and In is Vx minus 0 divided by 3. Put all these values in the KCL equation and calculate this Vx. Calculated Vx is minus 18 volt, and calculate the value of In. In is Vx by 3. So its value is minus 18 by 3. So calculated value of In is 6 ampere. Minus 6 ampere indicates the current will flow from B to A. Now calculate our RTH and calculate our maximum power. As we calculate, VTH is 18 volt, IN is 6 ampere. So for maximum power transfer to the load R, this is equal to RTH, that is VTH divided by IN, that is 18 by 6, and its calculated value will be 3 ohm. Now calculate the maximum power. Our maximum power formula is VTH square divided by 4RL. RL is the load resistance, that is 3 ohm. Put the values and calculate this maximum power. It is calculated as 27 watts. Thank you for watching the concept. Please like and subscribe my channel.